Everyone. So today we're going to be going over how flags work. Now, this is going to be very important because flags are things that can give you a lot more control over how a program works. So right here is an example of a simple program. It's got, let's try and make a little block diagram of it. So it's got clock input, got another input, and then it's got 7-bit output, 8-bit output. So, I guess before we get into making a flag, we'll go over how this program is initially, and then we're going to use a flag to modify it to something we want. So, register for our count and clock counter, and register to store the value of CLC slow. Got a parameter. This value is chosen to make it be slow. So, yeah, this always blocks. Draw that in the block diagram. So for every positive edge of the clock, we're going to add 1 to clock counter. And we're going to keep doing that until, excuse me. So we're going to keep doing that until clock counter is equal to width 2, which we define up here. And when we set width 2 equal to this, it'll invert clock slow that register, because this might be 0 at first, then it'll turn to 1, then to 0 again, and back and forth. And then it starts back all over again, where it changes to 0. So let's draw what that would be. Weird. So So what's going to happen is we're going to have our clock that's like a really high frequency coming in. It's going to be a really high frequency coming in. And then the one coming out is going to be a way slower frequency. And the reason why we do that is because we want something that's slow enough for us to see. So yeah, now that we've created our slow clock module with this always block, and let's all elaborate even more. You'll see on the positive edge of each of these things, clock counter is going to change. So it starts off at 0, the clock counter will become 1 here, and then 2 here, and then 3 here, and then 4 here, and it's going to keep doing that until finally it's equal to a really big number, this number right here. So oh, so yeah, after enough time, after the clock has been going for enough times, eventually the register clock counter is going to get big enough to be the same as width. And once that happens, both of these if statements are going to execute at the same time. So it's going to, on the very next clock counter, it's going to be 0 again, and it's going to repeat. And also, at that same time, the register storing clock CLC slow. Like, let's say for all this time it was 0. Right here, because the if statement executed, it turns to 1. And then 0, and it's going to count again until it's equal to 1000 again. And then it's going to go down and be 0. So yeah, that's like how it works. And we're representing that here. So yeah, we're representing that here. Now that we've explained how that works, let's go here. So we're gonna have another thing. It's gonna take in CLC slow, and if the input is 1, let's start up here. So we have our CLC slow. It's gonna be like this. Count. Here count is equal to 0. Here count is equal to 1. Here count is equal to 2. And it's gonna keep doing that until eventually count is equal to 8. And once that happens, it's gonna reset and then start counting again. And then down here we assign LED to be equal to count. Just like this is. That's just a small background on how this module works. Okay, now for the main part of this video, it's going to be going over how to make a flag. So this is the code. Let's program the device. If the input is 1, it's going to count. And this is going to be, and count is a register value. And we assign LED to count. And where is it? So yeah, this is where we mapped LED in the constraint file, just like this. Ah. So this is LED 0, this is LED 1, LED 2, so forth. That's how it's being mapped. So your count is a register. then we assign it to LED. And count will, right now it's 0, count is equal to 0. That's why the LED is 0. But when input is 1, on every positive edge of the slow clock, it's going to start counting. So let's do that. So if we physically hold this down, it's starting to count up. So 2, 3, 4, 5, 6, 7, 8, 0. And then it repeats again and again. So next. Okay. So yeah. Now you might be thinking, well, and you see how it's stuck there at 2? The reason why it's stuck there is because I'm not holding the button. If I hold the button, then it starts counting again. But if I let go, oh, what am I doing? But if I let go, it just stops. That's not good. So I'll show you guys how to make a flag now. So what we're gonna do is we're gonna create a register, call it drag flag. Let's initialize it to be equal to 0. To initialize stuff because sometimes your code won't work if you don't specify what it needs to start off as. So now we're going to need to make an always block, but instead of post edge slow, it's going to be post edge input. So this is input. It's going to be 0 all the time. But the minute we press the button, it's going to go from 0 to 1. And if we let go, it'll go back down to 0. On the positive edge of input, that's when all of the code that we write in here. So yeah, on the positive edge, when we press it down to make it go up, that's when all of the code that's in here is going to execute. So what we want to do is when that happens, we change flag to be equal to 1. And let's use non-blocking assignment. So that means press the button, it's going to change flag to be equal to 1. For all this time, flag is equal to 0. And then for all the time after, flag is equal to 1. And here, nothing happens because that would be neg edge. Only on the positive edge would it happen. And even if we press the button again, well, it's already flag 1, and the code changes it to be flag 1, so that wouldn't change anything either, so it's just going to be flag 1 forever. So what we would do, put flag in there. Okay, so let's generate the bit string and see if that does anything better. Doing it. I don't think that's it. Oh yeah, this is it. So then in here, you put the name of the thing that's giving you an error. And for us, that's going to be input. So that should fix that error. So that fixed it. Let's go to Hardware Manager, Target Auto Connect. Program the device. Okay, it's not showing well. Try that again. Okay, there we go. So as you can see, it's not counting. Before, we would have to press that center button right there and hold it. But now, we only have to press it once. And what it's going to do is when we press that button on the positive edge of us, right when we press that button, it's going to change the input value of this button from 0 to 1. And during that transition, this code is going to execute and it's going to set flag to 1. And then for this always block, before the button was pressed and flag was 0, this would not execute, so count would stay 0, which would mean LED would stay 0, because they're the same with this assignment statement. But since we press the button and flag is equal to 1, this if statement's true, meaning this executes, which means LED is going to be updated. So when we press it, we just need to press it now. We do not need to hold it down. But yeah, 6, 7, 8, 0, 1, 2. So yeah, was that now? You might be asking, well, what if we don't want it to repeat forever? We want to press it, make it count all the way up to 8, and then go back to 0 and then stop. Well, then we would have to create like another flag or something. So let's do that. So actually, we would not need to create another flag. What we would need to do is when count is equal to 8, hold on. So yeah, what do you think goes here? If you're really smart and you've got an idea, you might want to pause the video and think, and then I'll tell you if it's right or wrong. Okay, if you did that, what you know or should have known is that what we do is we set flag back equal to 0. So when we do that, it's going to execute count all the way up to 8. So when count is going up, it's going to show that in LED. But then when it gets back to 0 and resets, flag will be 0, meaning this will no longer happen and it won't count up. So let's do that now. And if you're watching this video, you might want to just skip the time that's going on for the bitstream generation. Sometimes I camera. Right now, so it's doing what it was doing previously, but let's program it with the new code now. Okay. So now that we have the new code where it sets the flag back equal to 0, we press this button, it's going to count all the way up to 8, and then it's going to stop, and then we're going to need to press it again. Interesting, nothing happened. Alright, so I figured out why it wasn't working. Before, we had it like this. We're on the positive edge of the input. We wanted to change the flag to be 1. And then the positive edge of CLC slow. If flag was 1, we wanted it to do this. And then if count was 8, we would do this and set flag to 0. And in Verilog, whenever you use 2 different always blocks to change the same value, nothing is going to work. And if it should give you an error, but sometimes it won't. Like it should give you the multiple driver error, but it won't always do that, and the bit stream will generate, and you'll think it's working, but it won't. So you cannot use 2 always blocks to change the same thing. What you have to do instead is do it the right way, where you use a single always block and combine them both into one. And then use an if statement to take care of the logic that was done by this one, and then the else if takes care of the logic that is done by this one. So, yeah. And then this needed to change to 9. Oh, and also, whenever you have an input signal and you're detecting whether or not something needs to happen to the positive or negative edge of that input signal, you need to use just an equal sign in the always block. You do not want to use non-blocking for something. So when using an input as a clock, like a button or a switch, like if you have something in the sensitivity list of an always block that is a physical input, like in this case it's the button right here, but if it were a switch or input port, always if it's an input, like one of those things, you need to use the blocking in the always block. So that's why in here, because of this, we use equal signs. Also, when you do it the right way, you will not need to overwrite the clock in the constraints file. So here it all is with the right way. I changed count to be 9 because this whole thing is going to behave more combinational, where when count is equal to 8, it's going to instantly change count to 0. So it's not even going to show, so you have to go up to 9. So yeah, in the constraint file, you do not need to use this when you do it the right way. So let's program the device, and I'll show you guys how it works. So here it is. And when you press the button, it goes all the way up to 8 like before. If you want to go again, You can do it as many times as you want. Oh, what am I doing? Let's show it. So, yeah, if you press the button, it'll go up. All the way up to 8. Press it again, and it'll just work. So, yeah. Now let's go through some timing. So for simulation purposes, let's just change this to being 5. And I wrote a test bench that you guys can look at. So if we run simulation, okay, that was bad. Let's change this to be, let's run simulation again. Okay, so here it is. So everything starts off at 0. We have our fast clock. We have our slow clock that got made from this always block. We have our input, which is our button. You press it briefly. That's what this is. You press it, it goes up, then you let go, it goes back down. And when that happens, flag goes high immediately on the positive edge of the input, so that's why that goes up right there. And then once flag goes high, on every positive edge of the slow clock, count starts incrementing, and because counts and LED are the same thing, due to the assign statement that is right there, whenever count increments, LED increments, which shows in the output of the lights. So yeah, on the first positive edge of CLC slow, one flag is 1, it increments again and again and again and again. But then finally, on the positive edge of CLC slow, when count is equal to 8, it goes back down to 0 because of this. Count goes to 0 and flag goes to 0. Actually, when count is equal to 9. So yeah. So that's how this entire thing works. And obviously, if you want, you need to have it be the right parameter to synthesize. I had it as this before. But for simulation purposes, it's really good to make this number small. Because if you do it when it's big, it's really hard to scale it to show like this. So yeah. This just shows how it works. So I hope you understand now the importance of flags and how to use them. So yeah, when the flag was high, it was counting, then we set it low, and then it stopped counting. So yeah, that's all for this. Thank you.